Hey everyone, and welcome to the second day of double and half angle identities. Today we're going to use our new information of double angles in particular with just some kind of basic trig work, but then also proving some identities. So similar to what we were spending last week on, we now have this extra component where we might have identities that we need to prove that involve double angles. And for the most part, it's going to be taking that double angle statement and then converting it using your green sheet into an identity problem similar to what we were working on, like I said last week. So in this first example, I have 1 minus the cosine of 2 theta, all divided by 2, and I'm trying to prove that that would equal sine squared theta. And for cosine, there's actually 3 different identities that I could choose from in order, like on my green sheet, it says cosine 2 theta is 3 different things. I'm confident you could use any of them in order to kind of prove this. Just for my own purposes, I went with choosing this 2 cosine squared theta minus 1. And we're going to kind of see what happens basically as I go through and do it. So I'm going to rewrite the left-hand side of my equation. But when I get to cosine 2 theta, I'm going to replace it with 2 cosine squared theta minus 1. And then this is all being divided by 2. It's important to note that when I'm doing that replacement, I need to be sure to put it in parentheses. That's going to highlight the fact that I need to do a sign switch on that -1 coming up. So this actually becomes 1 minus 2 cosine squared theta plus 1, all divided by 2. So from here, it looks like I can call this 2 minus 2 cosine squared theta, all divided by 2. And one thing I would point out, when prepping for this, I kind of crossed out all those 2's, which you might think violates kind of a fraction rule, right? So I can get rid of this one, this one, this one. But what I'm going to show this instead is factoring a 2 out of my numerator. So this becomes 1 minus cosine squared theta, all divided by 2 equals sine squared theta. And this is nice just to kind of show the fact that I can cross those 2's out. And I'm left with 1 minus cosine squared theta on the left-hand side, which actually just equals sine squared theta. So now I have that the left and right-hand sides are equal after doing that. So that is kind of the proof identity using a double angle. We've got another problem on the right-hand side, which is also probably something you encountered on your kind of practice work yesterday, where we have a double angle, but it's not sine, cosine, or tangent. It's actually something like secant or cotangent or cosecant. And what I would recommend doing kind of first is to switch that to being in terms of cosine. So I have this negative secant 2 theta. Well, in reality, I could write this as cosine 2 theta. So I made it the reciprocal, turned it into cosine of 2 theta because I have a double angle identity for cosine 2 theta. That left-hand side, I'm actually going to leave as it is for right now. And I'm just going to worry about my right-hand side, and that should actually be enough to kind of get me through this problem. I think one strategy that we'll probably be working on or picking up is that we need to work on the side that has the double angle in it, because it might be harder to see how to get from a expanded double angle back into a double angle. So I'd prefer to start with that side and make it more complicated. All right, so I was able to do that. And then you'll also notice that I chose a different cosine 2 angle, cosine of 2 theta identity for this. So here I've kind of picked this versus on the left-hand side, I ended up doing just 2 cosine squared theta minus 1. And the reason for that was I was looking at my left-hand side and noticing, hey, there's a lot of sines and cosines there, so I'd prefer to create them if I could within this step. So I can replace this cosine 2 theta using my identity to become this. All right. And now I'm actually not too far away. One thing I might just do is distribute this negative to my denominator. So that would give me negative cosine squared theta and positive sine squared theta in my denominator. So this I can actually just change the order on, and it becomes sine squared theta minus cosine squared theta. And I did that by distributing that negative to the denominator. And I also did that because if I look at the left-hand side, that's actually what I want to get to. And the last step is probably one that we haven't done unless you've done like one of the challenge, I think it came up on a few of the challenge problems. But if we look, I want to somehow find a way to turn 1 into sine squared theta plus cosine squared theta. And using my green sheet, I can just do that straight up because sine squared theta plus cosine squared theta is 1. That is just one of our Pythagorean identities. Okay, so for this last step, you would just look at your green sheet and see, oh, sine squared theta plus cosine squared theta is 1. Okay, and then this is obviously just going to equal basically our left-hand side here. So I'll just say we're good from there. All right. So that's probably the newest thing that you're going to be practicing today. This also should have come up on your homework. This is a situation in which we're given a trig value, but then we need to figure out what sine of 2 times that angle is, cosine of 2 times that angle, tangent of 2 times that angle. And all we know right off the bat is that cosine of theta is negative 3/5 and theta is in quadrant 2. So this is where we go back to drawing a triangle in quadrant 2. Given this information here, I know that the adjacent side is negative 3, and I know that the hypotenuse is 5. We like the shape of this particular triangle because it's a 3, 4, 5 triangle. So I can put in that opposite side is a 4 and it's positive because my y-coordinate is positive. But this allows me to figure out all these other trig values. So I did write down the green sheet identities of sine 2 theta, cosine 2 theta, and tangent 2 theta. And now I'm just going to basically be plugging those in. So sine of 2 theta is equal to 2 times the sine of theta. So this is my theta in here, so it's 2 times 4/5 times cosine, which is negative 3/5. And then that's going to give me an answer, and I'll simplify it in just a sec. I found that the double angles aren't that bad to simplify. So cosine of 2 theta would be 2 times cosine squared theta. So this one we could have actually done without our whole triangle. But cosine of theta is negative 3/5, so I'm just going to square that kind of when I'm done. And then I have tangent of 2 theta. Tangent of theta is opposite over adjacent, so that would be negative 4/3. And then this is going to be 1 minus negative 4/3 squared. So for these, you can simplify down if you want to practice some of that fraction work to a single fraction. I think it's easier on some of these than others, like this top one. Looks like 8/24 over 25, so this would be negative 24/25. Here, if I squared my negative 3/5, I'm going to get 9/25. So this looks like 18/25 minus 1, which is 18/25 minus 25/25, because that's the same thing as 1. So I get -7 over 25. And then this one through kind of a similar process. We could square, looks like we're probably going to want to find a common denominator in the bottom, multiply by the reciprocal. But at that point, I think we should be okay to succeed from there. All right, so yeah, apologies for not putting up that video yesterday. Hopefully this is starting to make some sense, and I'll see you tomorrow.